And one of the algorithms we want to talk about right off the bat is bubble sort. Bubble sort is a sorting algorithm. We've been discussing arrays, and let's talk about how we can sort arrays. Now, I will tell you for the sake of brevity, I'm not going to show a full bubble sort here in this code. I'm going to show bubble sorts when we get to our coding, when we get to our coding labs. But bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they're in the wrong order. It's used for sorting elements in a list or an array, and it relies on comparing elements to determine their order. You don't need anything else to run a bubble sort. You can do the thing with the array you have on hand. The algorithm overview is this. You start from the beginning of the list. You compare the first pair of elements. You compare the adjacent element and determine if they're in the correct order. If they're not in the correct order, you swap them. You continue doing this until every element has been done, and then you continue repeating that process until the algorithm reaches the end of the list. If no more swaps are needed, you stop the algorithm. And it looks like this. And you can see how 6 is going to bubble up until it gets to a certain level in the algorithm. Now, of course, you're looking ahead maybe, and you're seeing that 8 is bigger than 6. So we can jump on to 8, which is going to bubble up. There's not a lot to discuss here. You can see that 5 is being compared to 3, 5 is going to be compared to 1, 5 is less than 6, so at that stage 6 is going to start bubbling to the top. But 6 is actually less than 7, so now 7 is going to bubble to the top, and 7 is going to go until that last element has been reached. Now you'll notice that every time we iterate through the list, that now the second to the last element is the second to largest element, so we are good at this point. And we're going to go here, and you can state for the record that that 6 should be the next element that bubbles up to that third place. Sorry about the glitch in the screen there for a second. Now you know we're going to be back to 5. 5 needs to get up there. Now, in a general bubble sort, we continue to compare until we get everything to the end. But making it more efficient means that we can just stop when we've reached no more swaps. So we're not going to go through this again, but y'all see how the bubble sort works. So for bubble sort, on average, bubble sort has a quadratic time complexity, making it less efficient for large databases. Best case scenario, if the list is already sorted, you have a linear time complexity. But we're not worried about best case scenarios in Big O. We're worried about worst case scenarios. And this happens when the list is in reverse order. And that leads to the highest time complexity, O to the n squared. Now you'll find that bubble sorting is space complexity, is good at space complexity because it's an in-place algorithm. So it doesn't require additional memory space to run the algorithm. It runs on its own with just the data structure we have in place. We've already kind of noted this, but the bubble sort is very easy to understand and implement, and it works well for small data sets. The disadvantage is it's inefficient for large data sets, and it's not really suitable for nearly sorted data because once it finds one element out of whack, it's going to go through the whole list and take forever, and we don't want that to happen. So in this case, it's not the best scenario for nearly sorted lists or large data sets. Let's look at a different sorting algorithm.